Welcome to our video measurement and motion, measurement of volume and density. Our subject is physics, class 6th to 10th. Now we will start our video. In this video we will learn about the measurement of volume. Here measurement of volume of solids and measurement of volume of liquids. See here, first of all, measure volume of solids. How to find the volume of solids? Here again, volume of solids, two categories are there. First one is the volume of regular solids, means that solids having particular shape. When you are finding the volume of regular solids, we use some formulas. For example, when you are find the volume of cuboid, the formula is L into B into H. Here L is nothing but length, B is nothing but breadth, H is nothing but height. Next, volume of cylinder, here pi r square h. By the using the formula of pi r square h, we can determine the volume of cylinder. Here pi is nothing but one constant value, that is equal to 22/7. The pi is equal to 22/7, that is equal to 3.14. This is the fixed value. Next, r is nothing but radius of the cylinder, h is nothing but height of the cylinder. By using pi r square h, we can determine the volume of cylinder. Next one, cube. When you are observing the cube, in cube is having 3 equal sides, so that's why the volume of cube is equal to side cube, side into side into side. By using this formula, we can determine the volume of cube. Next one, volume of sphere. Volume of sphere, the formula of volume of sphere is 4/3 pi r cube. Here pi again 22/7, 4/3 also constant number, r is nothing but the radius of the sphere. By using these formulas, we can determine the volume of different regular solids. For example, here see here here total 4 figures are there. Here first figure indicates what here? Cuboid. First figure indicates what here? Cuboid. When we have to find the volume of cuboid, we have to use the formula L into B into H. L into B into H. Here this is the L, this is the B, this length is the H. By using formula of LBH, we can determine the volume of cuboid. Next one here, volume of cylinder. Volume of cylinder formula is pi r square h. Pi is equal to 22/7. R is nothing but radius of the sphere. R is nothing but radius of the sphere. Height is nothing but height of the sphere. Height of the cylinder. Here r is nothing but r is the radius of the cylinder. Radius of the cylinder is r. Height of the cylinder is h. Then volume of cylinder is nothing but pi r square h. Here pi is equal to 22/7. Next, third figure is the cube. How to find the volume of cube? The formula of volume of cube is nothing but side cube. Side cube, side into side, we can find the volume of the cube. Next, sphere. Next what here? Sphere. How to find the volume of sphere? Formula 4/3 pi r cube. Here r is the radius of the sphere. R is the radius of the sphere. This is about the volume of a particular or regular shaped object. Next one here, second case in the volume of solids. Second case is how to find the volume of irregular solids. How to find the volume of irregular solids? Find the volume of an irregular shaped stone using a measuring jar with some water on it. By using this method, we can determine the volume of irregular shaped stone. Irregular shaped stone means the stone is does not having particular shape. Okay, in this case we will take a measuring jar and with some water we can find the irregular shaped stone volume. See here, this is the diagram. Okay, see here, this is the measuring jar. Measuring jar is having some units. This is all milliliters is there. See, when we are in this measuring jar, we have to take water. Okay, before going to stone, we have to find the reading. The water level is how much is there. See, by this two figure we can find out the lower meniscus. Why? Because we taking what here? Water. Water is nothing but transparent liquid. That's why here by using the lower meniscus, the reading is A. In this figure 60 milliliters is there. Next to second step, after the completion of this reading, we have to enter into the stone by using a thread into the water. In that situation, the water level will be automatically increases from 60 milliliters to another level. In that situation, we have to find the water level. Here we observe here how much water level is there. 80 milliliters is water. 80 milliliters is there. That's why when we have to enter the stone into the water level automatically increases up to 60 milliliters to 80 milliliters. That's why we can measure the volume of the irregular solid. For example, see here, when without stone the reading is initial reading, that is A. Here A is nothing but how much we get? 60 milliliters. After inserting the irregular stone, the volume of water will be automatically increases. So that is the final reading, that is called B. The final reading B is equal to here how much? Here 80 milliliters is there. Okay, when we have to subtract from B to A, we can get the exactly volume of the irregular solid. Volume of the irregular solid, that is nothing but volume of object is equal to B minus A. We will get the volume of the object. By this process, we can determine the volume of solids. Which type of solids? Irregular shaped solids. We can find the volume. This is the volume of solids over. Next we will go to volume of liquids. See here, volume of liquids is there. The amount of liquid that can fill a container is called volume of liquid or capacity of container. Generally, usually we take liquids in containers. So when we are find the volume of container, the container volume is equal to the liquid volume, which liquid we have to take in that container. Here volume of liquid is nothing but capacity of container also. Volume of liquid is nothing but capacity of container also. Okay, volume of liquids can be measured using different containers called measuring jars. Now only completed. By using measuring jars only we can determine the volume of liquids. Volume of liquids here. Generally volume of liquids in uses in which type of units here? Liters and milliliters. Liters and milliliters. Okay. This is the volume of liquids. See here, some diagrams are there. By using these measuring jars we can determine the volume of liquids. First diagram observe here. This measuring jar is having some readings. So by using this measuring jar we can determine the volume of liquids in milliliters. Okay na? See, observe this figure. Next figure is there na. Here 500 milliliters, nothing but half liter, 1/2 liter. By using this jar we can measure the kerosene and oils. Okay. Next third one is there. Here also 500 ml is there. 500 ml is half liter, 1/2 liter. Okay. By using this measuring jar we can measure the milk in our daily life situations. Okay. Observe this figure solve. Okay. Next one, fourth one here, 200 ml jar also is there. By using this jar also we can determine the volume of the liquids. Volume of the liquids. Next density. Density. What is mean by density? Density is nothing but the measurement of how tightly a material is packed together. When we are observing any object, that object is consisting so many small particles. The small particles how tightly is gathering, that is called volume, density of the object. Technically, according to scientific, the density is nothing but it is defined as the mass per unit volume. Mass per unit volume is nothing but m by v. The symbols of density is d or rho. In case of rho, we have to take in liquid cases, we have to consider the symbol rho. Rho is nothing but this is the symbol of rho. This is rho. You have to write like this only. Okay. Here rho is equal to m divided by d, m divided by v. Yeah, rho is nothing but density, m is nothing but mass, v nothing but volume. V nothing but volume. This is the formula of density. See here I am explaining. Density is equal to m divided by v. Here when first case v is equal to constant means volume will be constant. Volume does not changes. Okay. For example, I am explaining with one example. I am taking two containers. Two containers have same size and same volume. In first container filled with water and second container filled with sand. Okay, which container is having higher mass? Automatically, obviously we can say the container which is having sand, that container is having greater mass compared than the water. Okay, that's why when we constant, v means constant means what? Size of the container constant. Now v is constant. In that situation, more mass, more density is present. Less mass, less density is present. Okay, means in this situation mass is increases, rho also increases. Mass is decreases, density also decreases. This is represented by mass is directly proportional to rho, or rho is directly proportional to mass. This symbol indicates directly proportional. Directly proportional is nothing but one quantity increases, another quantity also increases. One quantity decreases, another quantity also decreases. This is the first case. Now I am taking second case. M is equal to constant. M is equal to constant means M does not change, mass does not change, whereas volume will be changed. See here one example I am taking. 1 kg of salt and 1 kg of cotton. I am taking 1 kg of salt, 1 kg of salt. When in this two we have to observe mass is same. Why? Because here also 1 kg mass, here also 1 kg mass, means mass does not change. Mass does not change. Mass is a constant. Mass is a constant. When mass is constant, when you are observing the 1 kg of salt occupies how much place? 1 kg of salt occupies less place compared to the 1 kg of cotton. Means here 1 kg of cotton occupies more space compared to the 1 kg of salt. Nothing but 1 kg of cotton is having more volume compared to the 1 kg of salt. That's why volume increases, density decreases. Why? Because more volume present in equal mass presenting in occupies more volume. That is that in that situation density will be decreases. When volume is low, density will be high. Here opposite direction is there. In this case same direction is there. In this case opposite direction is there. That's why rho is decreases, V increases. Rho increases, V decreases. V increases, rho decreases. V decreases, rho increases. Okay, this is the inversely proportional. Rho is inversely proportional to V, or rho is proportional to 1 by B. Both are same. Okay, now rho is inversely proportional to V. This how to call this one? Inversely proportional to V. Rho is proportional to 1 by B. Both are same. Okay, now this is the when M is constant, what relationship between the density and volume. Okay, in future classes you will learn more, don't worry. See here, when M is constant, M is more, rho also more. M is less, rho also less. When M constant, V volume is high, rho will be low. Volume is low, rho will be high. Okay. Next see here, now SI units of density. Already we know what is the formula of density, M by V. Okay. In SI system, what is the units of mass? Kg. What is the units of volume? Meter cube. That's why the density units also kg divided by meter cube. Kg divided by meter cube. Now applications of density in our daily situations. So many times we observe density. For example, it allows to determine what substance will float and what substance will sink when placed in a liquid. For example, I am taking water. The density of water is 1. The density of water is 1. When the object is greater than the 1 density, means greater than the value density of water, the object will be automatically sink in the water. When we have to take one object, observe the object density. The object density is the less than the 1 or less than the water density. Automatically the less density object float on the water. See here, when we have to take any liquid, you have to consider the density of the liquid. The object which is having lower density compared to the liquid, the object will float on the liquid. The object will have higher density compared to the density of liquid. Automatically the higher density object sink in the liquid. See here, one question is there. Rohan's father bought an oil can. Rohan's father bought an oil can. Rohan wants to find the quality of oil in liters. Quantity of oil in liters. Quantity of oil in liters. Help him find out the volume if the dimensions of oil can 20 centimeters, 10 centimeters and 5 centimeters. When we are observing these figures, I think this, according to this figures, the container shape is cuboid. How to find the volume of cuboid? Formula V is equal to L into B into H. According to formula, V is equal to 20 into 10 into 5 centimeter cube. Here we will get 1000 centimeter cube. 1 centimeter cube is nothing but 1 milliliter. That's why 1000 milliliter. Totally we get 1 liter is the volume of the can. The volume of the can is equal to how much? 1 liter. This is the answer. In next video, we will discuss in next topics. Thank you.